All right. All right, so I'm gonna go ahead and get started for the final review. I'm also recording this. All right, hopefully that message won't cause a problem. So just a quick review, you guys got your final exam on May 20th in EMS E180, that's 50-minute exam. It's gonna be from 12:30 to 1:30. If you have accommodations, you have EMS E169, does that sound correct for all you? You're allowed 3 sheets of paper, and it's expected to cover all material from lectures 8 to 14, homework 4 to 6, lab 7 through 14, and project 2. Let me close the door. All right, so basically what I'll be doing is I'll be going over the lecture notes, kind of pointing out things that I would probably say is important, explaining any questions, or answering any questions you might have. As I mentioned before, the final exam is not written, so I haven't seen it. I don't have any prior exams. Prior classes actually did projects within recent years. And I don't have my prior exam from way back when, but I wouldn't expect it to be anything the same. We covered different topics. So, yeah, Professor, we will eventually write this, and I think if there's something that I missed on here, if I end up seeing it and there's something that I missed on here, I would more than likely send out an announcement and just say, hey, I won't give you an answer, but I'll say, make sure you know this particular block. So I won't do you guys dirty. All right, so if we begin on March 27th, his lecture that week of the 27th, he basically goes over the matrices. The important part is kind of understanding the basic structure of the matrix. More so the general code. Let's do this here. So when we have a matrix A, and I'm just creating some numbers here, that we understand the general format. So we have A, that this creates a row here, and then this creates, not colon, a semicolon, my bad, creates a new row here. So understand that this creates that matrix. Yeah, beautiful, that's good, all right. So understand how the basic structure is, kind of what's going on. Does anyone have any problems kind of understanding this is how I make a matrix? I mean, it's really pretty simple. You guys have done it a lot already. But if there's any confusion or had any questions at some point, now's a good time to ask about it. Some of the commands to kind of watch out or to kind of pay attention for is obviously when you want to select the whole row. So here we're using live script, but if you see, we're going to go ahead and put semicolons, or not semicolon,
Just colon.
colon, yeah. But we're going to go ahead and put colon there to signify we want all the rows. So in this case here, we're going to do colon first, and then we'll say the first one. And then we'll do the opposite here. So, and so here on the first one, we're showing that we put the colon in the first spot. So we have the first, all the rows showing in that first column. So kind of understand what colon does here. That's something I would generally ask. It'd be like I would ask a question of multiple parts, and I would have stuff like that, kind of concerning matrices. So how to create a matrix, take these numbers, arrange it in a matrix. How to separate a matrix, obviously how to transpose a matrix, where it's the apostrophe. Let's do this here, I want to show you the original one. So, and you'll get more into transposing matrices if you take E234 at some point, or if you have it already, or if you're doing so already, then you already kind of know about it. Some of the other commands too that would probably get asked. I mean, obviously we had our random 3 ones, which we'll say, let's make it a 5 by 5. Our zeros, and our magic. So if you look here, you know, our random picks random numbers. I did a 3 by 3 matrix. Our ones takes a matrix, makes a matrix of ones. Our zeros, and then magic is the numbers which you did on the homework, and I would assume that might get asked, even though it really has no purpose, you know, it's kind of like a barroom trick, I guess, you know, for mathematicians.
So what does magic do again?
So if you take the sum of like all the columns, so if you sum up that column, it's all the same number.
Total?
Yeah, so diagonals are the same,
Oh, wow.
the rows are the same. I mean, yeah,
Nice.
yeah. But there's no real purpose to it. Like ones and zeros, you can use for finding eigenvalues and things that kind of have some sort of relevance. Not so much that though.
Let's say we want to do a random matrix, but we wanted to have it like in between 2 numbers. Is that a syntax that's inside the parentheses, or is that something different?
Yeah, so I would assume, let's see. Size 2 class name, I'd have to look it up.
Okay, never mind.
But what I would do is probably, I would limit it. I'd just say, you know, my A variable is a set between that number. I'd say random set of numbers.
Okay.
And then just have, instead of a 3, I'd have, you know, something along that lines in there. But no, I'll get back to it. It'll distract from everything here. Remember the one homework assignment where we did when you want the diagonals and the flip left and right, flip up and down. We'll get the mesh grid here in a second, this one here. So remember these commands? Just kind of, I'd have it on your sheet. I mean, it's kind of, if you look at the name, it's kind of explains itself, but flip left, right, flip up and down. This one more so for the diagonals, you know. Magic. So mesh grid, he called it mapping vectors. It's kind of difficult to explain. The help doesn't do a great job of explaining it too. So, not that one. So if we go to our handy dandy help, and we put mesh grid, all right. The help basically says 2D, 3D grids. It's like, all right, thanks. You know, you can get some descriptions here. The best way to explain it, it's kind of like with fractions and taking the common denominator. So if you have a 3 by 3 matrix and a 2 by 2 matrix, it's going to find a common denominator to kind of make it into an equal matrix. So to kind of show you a little bit here. Here they have a 1x3 and 1x5. And they basically make a 3x5 out of it. So it finds an equal ground, so a common denominator. That's the best way really I have to explain it. That's how we were able to do some of the homework problems where you had different arrays, different size arrays. We were actually able to say, find this common denominator where we could sit there, run these problems. So, anyone have any questions on the mesh grid? I know I've covered it a bunch of times in here, so, but I can't see a lot of questions being asked on it, but I think if you understand the concept, have something on paper to kind of substantiate, I would kind of put what he has here. So I would assume if he's gonna ask anything, you know, it would be along the lines like, you know, what's the command of the map vectors? And then he texts these practice problems. So generally with matrices, that's about it. I don't think of anything else off the top of my head. Anyone got any questions? All right. So plotting is going to be the bread and butter of engineering. So as always, you know, make sure you have titles, your labels. I've stressed it kind of enough, like over the homework, so you guys should kind of have it down pat. But some of these other commands, you could add in there. You might want to sit there add in some of the commands from project 2 where, you know, like for example, is axis equal, I think. Just if you got 3 sheets of paper, so you can't go wrong, lots of real estate to write stuff down. I would kind of just put some of the stuff on there. Hold on, hold off. So basically hold on is, it tells MATLAB to kind of don't exactly produce the plot yet until everything's considered. So in this case here, they draw two curves, and ultimately that's what it does. If you would have just did the plot with the one curve, it would have produced the one curve first, and then you would have had like another plot with a separate curve, or it would have just, it depends on the version of MATLAB, MCode or the live script. But ultimately, the hold on signifies that you want both on the same plot, on the same chart. So it kind of pauses plotting to compute everything. Does that make sense? All right. Plot, I would also kind of, let's see, I think it was, so I would kind of say, like, you don't have to write all the identifiers to make different colors. I wouldn't ask, like, how do you draw circles like this, or how do you do a line with circles? I don't think it's a fair question, to be honest, but I would kind of understand what's going to make it, you know. So for example, if you look up here, they basically have these line specs and name value. Make sure you kind of understand that there's a trigger that kind of follows what your plot should have. And he has it listed as this. So, you know, I would probably have something like this on my sheet, just in case if he asks, you know, what kind of flags are used for plot to kind of change maybe the type or the color or whatever. I would probably just have that. Even though it's a little bit different than the help, but no matter what, you can't go wrong going off what's he's provided, even if his, for example, if he had an error or mistake there. Always use that. Remember the homework assignment where we added the legend and then the text, kind of those commands. I think it was it 4? Like problem 4 or something. Understand about the axis. So when you take the axis and you put new points in the axis, you're kind of zooming out. You're not changing the dimensions. So I know a few people had that wrong on the homework. So when you're changing, well, let's see. I got to remember I'm trying to record it, so I want to do it on MATLAB too. Right. So if I have x linspace -6, all right, plot x, all right. So when I do axis, let's say -2, 2, -10, 10, -6, 6.
I think you need the brackets inside.
Yeah, that's what I thought. Yeah. Oh, inside, huh? Alright. Wow. Alright. How come that looks weird? I don't think the computer's liking it. Should have been more of a sign. Anyhow, my point is, I don't know why it's plotted all weird now. Anyhow, we zoomed out, so when we changed the axis, it went from, before it was 1 to -6, now we took it out and put it at a different scale. So understand that, kind of what that does. You don't change the actual domain, the domain's never changed. It just zooms out the plot. I don't know about these here. You could add this stuff. I think would be kind of not nice to ask this stuff, but I leave that to your own discretion. Subplot, understand subplots. So subplots is making multiple smaller plots using, kind of the figure space of a normal plot. So kind of understand what the numbers do. So here we have plot 1 and plot 2. This one takes a width of 2 with a height of 1 and puts it in position 1. This one, same thing, width of 2, height of 1, puts it in position 2. So that's kind of, the first number is the width. bar plots, I would probably write down, you know, how to have bar plots, the pie plots, the histograms, at least understand what the histogram, how it's created. Did you guys do them in labs? Did you make more plots like these, or?
Yeah.
Okay. So 3-dimensional plot. Understand the contour, the surface plots. The one thing that people made a lot of mistakes on, peaks is kind of numbers. It creates sample data, obviously, as here. It's not a part of the contour function. So you don't use peaks unless you want to sit there create plots exactly like this. So it's kind of like lens space almost. So kind of, those are variables like kind of consider. So this is the actual contour part here. Like this is the actual plot data. Surface C is surface contour. So these are the commands that really matter. Additional types of plots. I would ask a question, you know, names 3 kinds of plots or something. So that you could use it in MATLAB, something like that. So you could write something like this, kind of what they do. Log might be a more common one. Semi-log is not so much common, but it's used a bit. F-plot, I mean, you kind of do the same with normal plot. So, I mean, I'd kind of put that, I'd take it and put it on my sheet, just have myself covered. So any questions on plots, or did I miss anything? So functions. All right. Does anyone here not understand functions, like, needs it like really, really covered good? Because this is gonna be probably a bread and butter type thing on the exam. All right, so I'll quickly go over it here. So with a function, obviously, the way I always start functions, or as I kind of preach, is go to live, you know? Pick one of the functions. You could start one completely from scratch with an M script or a live script, but I just go to the new function, and you got a template of what's going on. So sometimes you might not remember everything, but in this case here, it gives you kind of the breakout. Now, MATLAB itself functions kind of reading from the top down. So it's going to sequentially read each line when you write your program. In this case here, so the first thing is the word function, which identifies that this file is going to be a function. Now, we have our output arguments, which will be the end result of the function, identified here. And then we have ultimately our function title and our input arguments for our main line of code. So to be very clear, this is completely separate from your MATLAB main line of code. So if I sit there, I'm typing, and I have, well, I'll tell you what, let's not just do that. Let's do.
When you do that, does it save just as an M file?
So it technically saves it as a function file, and it's kind of difficult to see, but this is an f of x right there.
That's so cool.
Yeah, so you want to make sure that it's in your same directory that you're working on, but it identifies that this is a function. So
I've never seen this before, so this is awesome.
yeah, all right.
The new function thing, that's
Yeah. Yeah, so I mean it gives you kind of an identifier just looking at it. The names are pretty easy, at least with the homework, so it says distance and height.
that's nice.
trying to think, not the 306 homework. So this is my own homework. Not what I want though. Now. What's going on? Well, you know what, I'll just open them. So this one was a homework assignment. I would for sure I would for sure understand, or let me repeat it. I would for sure understand what's going on here. Not fully understand. A function is really, so MATLAB itself, I gotta use a chalkboard, so whoever's online is gonna miss this part, I guess, but ultimately, here's our main line of code. Here's the main MATLAB. All right, and it's basically a box above everything. Now, MATLAB has individual libraries. When you'll get the Simulink, you'll do some other things depending on your courses. But each of these libraries have different code as functions. So common ones that we use are sum, plot is actually a function. Anything average, mean, median, all of those are functions. Those are built, hard-coded in functions. Now, sometimes, whether it's research, business, you might need to create something that's going to fit and tailor to your needs. And that's what this ultimately does. So you're making your own code to add to your library, I guess the best way to put it. So fully understand what's going on, that basically you're putting in this variable, or these two variables in this case here, for this function that's called distance. You're going to do something to it, and you're going to have an output. In this case here, I had I had the math line, and then I have the output line, which could have been condensed. But as soon as this function's done, this output variable, poof, it doesn't go to your main line of code. So if you sit there, run your code, and you have distance, so you can't say x equals distance, or not distance, output. All right, you'll get an error. So if we run it, 100. And then we do y equals XX. And then I'll put y. So you'll get an error here because it doesn't recognize what output is. Even though we have it, and as you can see, it ran there. But even though we have output here, or I can put even dist, these variables are temporary. They're only there for that function. So ultimately the answer is here. Y is the answer because it ran it through here. So the flow is, we put in our variables, it gets put in here, and then this will spit out the answer. So output is actually the function you run. So it's real important to make sure you understand that part. He goes into a few examples here. multiple inputs. We just did multiple inputs. You did it on your homework as well. Local variables, we kind of talked about that. Anonymous functions, okay? You guys did it on your homework. Anyone not understand it? All right. So anonymous function is a function you make on the fly. It's simply triggered by this here. So when you sit there say y1 is equal at x01, you're saying this is my function name, y1's the function name, my anonymous function is the add symbol with this variable, x1. So anything after that becomes your function, your line, you know, of what the function you wanted to do. You really can't do too complex or too in-depth functions with it, but you can do something like a quick computation, for example. I don't know how much someone would use it, but I could see some value to it. Path tool, add path. I would put definitions down. I really haven't used anything. I doubt he covered it. Doesn't sound like he did, or too much into it. Logical. So, as I mentioned, this is as before we started. So this is kind of what you did with Excel. So this is kind of going back to the beginning of the semester, where you have your Boolean logic. Understand the symbols. Make sure I would have this in a little sheet of paper. Just kind of have these symbols down. I wouldn't expect too many people just off the top of my head. Just remember what's not equal signs. You know, but less than equal. Those are real common. I definitely have those. These here, and ors. These are all part of the logic operators. If you guys did more coding or more programming, then you know it'd be really like random access and have it there. But I wouldn't expect too many. So definitely have it on your sheet. Make sure to have these. So Professor Yayawi, he's an applications guy, so have these written down on your sheet. What the oval does, what the diamond does. Understand what they do, what a decision point is. Kind of understand how a flowchart works. I could definitely see him asking about that. Like, I think a reasonable question would be, you know, what happens when X is whatever, you know, 11. So you would expect the black to be displayed, or what happens if X is 9? You'd expect nothing or whatever. So understand the flow. All right, and I will go into the loops actually now, because I think this is kind of a good spot too to kind of go over, at least if and then. I think the next one is loop structures. So if else, all right, so basically you have different kinds of loops. If statements are simply that. So if you have code and you pose a question or ask the logical question, if X equals something, do this. If not, do something else. These could be stacked in many ways. You could have if, and it goes directly, do this. It could go directly to an else, where it terminates there. And then with MATLAB, you always have to end with an end with your loops and your if statements. So it always comprises of these components. So if, else, and then. So remember those. You could also have else if. So elif, So you could have, if it's this, if it's this, or if it's this, or in the last, else do that, and then end. So it's not just two options, you could have multiple options. So the elif is the multiple options, if you wanna add more to it. And there you go, or else if, that's what he has, my bad. So the correct terminology is else if. Elif is Python. So in this case here, is that if you enter the value of x, if you say it's greater than 1, it would follow the sign path and go to the end. If it's 5, it would do the log path. Or if it's 11, it would just go straight through with no answer. Does that make sense? All right. So any questions so far? Come on, this is exciting stuff here. It's math. I mean, ultimately, at the end of the day, it's math and it's computer programming. So, switch case, I don't know, I've never used it. If you want to put that in there, it's kind of the same principle. But you could have it there, this menu. Yeah, I mean, I don't know how much you talked about it, but I don't think I've ever used a switch case. For and while loops. All right, so for and while, basically, these are kind of bread and butter type things. They're quite commonly used in MATLAB, quite commonly used in programming in general. If you ever take ME101, finite element analysis, you'll use it. You should use it in System Dynamics 302, ME302. But ultimately, for loop is kind of what it says on the tin. For whatever you have this particular instance, let me see his examples here. Not good. I'm not a big fan of his examples. All right, well. All right, so let's say I should have pulled something up here. All right, so if I have an array, let's say I linspace 1 to 20. Yeah, we'll leave it like that. All right. And I have 4 I greater than 1. You could have n equals a plus 1. And then it ends. All right. And then we could do display. Let's do that. This should be simple enough here.
Is it a dot grid?
I don't know.
Is it equals?
I don't know about equal. I'm missing something.
I think A is always greater than 1, right?
Oh, yeah.
That's the space.
But that's not the problem. Let's say 10 here. It's something stupid that I forget. For C equals. Invalid use of an operator. Okay, let's do this. Because apparently mine sucks. Also, when you do does it not show H? All right. So, real quick, basically, so if you look at this code, we have a variable s equals 10. We create an H matrix of zeros where it's a 10 by 10. And then here we have for C equals 1 through S, so 1 through 10. It makes an array there. And then basically it does this mathematical function here where you ultimately, it adds it to that in each individual spot depending on its count number. So for every instance of C, well, this one might be a little bit more complex than I want. Let me do this. My apologies. Give me 1 second. So let's say x equals C plus 2. All right. So ignore the H zeros, but basically we have C, and where we have it go from 1 to 10. But in this case here, so it's going to take the first instance when C is 1. So when S is 1, it's basically going to take 1 and add 2 to it. So C is 1, and then it's going to keep doing it for 10 counts. So what you can see here, it goes from 3 to 12, but that's because it happens 10 times. Now if we said S is 7, all right, it only does it 7 times. So ultimately the whole punchline is the for loop does it for a set count number. So when you have 3 times, you could have 30 times, you know, get a bunch of numbers. You could have it 300 times. It's gonna do it. Did I do 3,000? Anyone double dog dare me? All right, you talked me into it. All right, so anyhow, it's gonna do it all that times. So it's still working on it. So basically 4 is a count, all right? Now while is real similar to that with the fact of the main difference is there might be an infinite amount of occurrences this happens. Like 4, you're gonna have a set number. You're gonna know it's either 10, 20, or some mathematical number, integer value. While it might be a true statement. You could have it where, you know, while this button is not pushed, print this button's not pushed. And as soon as someone prints this button, it'll stop doing the while loop. It'll finish up that while loop and that's it. So they go hand in hand. It's just, one's a set number, one is an unknown amount. So anyone not understand loops? All right, so it's basically dog running around trying to catch its tail. Nested loops, that's what I had with the one example. It's basically, nested loops are loops within loops. So here we have for loop, we have another for loop. It's all loops inside another loop. There's nothing wrong with it. In some cases, it's beneficial. break commands terminates the execution of a loop. That's kind of a sloppy way of doing it, so it's not recommended to use break commands. But I think you might want to know it for your exam. Continue command, it could be asked. I don't know about this stuff here. How to improve your code performance. Sure. All right. So, symbolic math. I didn't see what was on this slide beforehand, so I can't say, what it relates to. But you guys are all engineers. You've actually been doing symbolic math this whole time. When you go do algebra, and you have like x squared or y squared, or that's part of symbolic math. You're basically using symbols to solve for math. And MATLAB could do kind of the same thing too. You could do it in Symbol Lab, you could do it in Wolfram. So I'm sure you guys had lots of experience, just not with MATLAB. But yeah, so sims triggers that these are symbolic variables. I would have some of these, like some of these commands that he has listed here. I don't know why I got that wrong. What's wrong with it? Anyhow, sims. So if we have f naught, x, y, z, we go ahead and run it. And it's supposed to show, I don't know, a equals f naught plus x minus z, all right? So basically, we made a system of system of variables that are symbolically represented, and then we made an equation from it. So in this case here, I used f naught. If you use an underscore, you'll actually get the cool little subscript. At least with LiveScript, it does. And then you got all the other variables there, and then you have different options. So you could actually solve different variables. So I would go ahead and write like the commands he gives here and kind of understand what they do. So make sure to go over this one. Like this, what day was it? I don't know, whatever. Symbolic mathematics. It was the recent lecture. I think it's your guys' last one you had here. So make sure to kind of go over it. I would ask questions on this part. But it's basically algebra. Best way to put it, Differential equations. And it's probably the newer content, so I would expect you guys to kind of know it ahead of time than the older stuff. So have this like kind of at least understand what the commands do. If you have room, But you guys took the midterm already, so you kind of know exactly. I would expect it to be structured the same way and similar. Really, that's kind of it. Go over the homeworks. That's kind of been stressed quite a bit. Glance over your labs. But they're all kind of the same things that you guys have done already. If you guys ever have questions, obviously you can just email me. I got stuff going on too. I got 2 exams next week myself, so if I get back to you soon, that's great. If not, kind of be patient with me. But I think I've been doing good myself on responding back. but yeah, any questions, anything, like on anything, so, yeah, about an hour, not too bad. That's all I got, so, all right. So, thank you all for letting me PA, you know, here, this is an experience I'll never forget.
The only reason I passed